Go.
Welcome, and thank you for joining us on this fine Saturday morning at the STEM Symposium 2015. We'd like to first thank our sponsor, our fearless leader, Chris Joe Irby, and we're here today to address the topic of conservation of energy. Here with me is Valerie and Dan, and we're going to talk about how, what we've learned today about the catapult.
Okay. We learned a lot about energy and the conservation of it. We did some trials with a yardstick, and we placed the catapult at the end, and we tried to hit a target. And we did several trials to do that. And so we learned all about the types of energy it took to do that.
Okay, so how does the law of conservation of energy apply to this complex catapult apparatus, Dan?
Well, the first thing we do is we find our potential energy. Upon the release of that energy, we have kinetic energy with the marshmallow launching, and then the loss of energy through friction, which is not actually loss, but a transfer. And then what we discovered about the conservation of energy was that variables really affected the trajectory of the marshmallow. If we did not keep our variables, our placement of the catapult in a consistent fashion, the pressure we applied to it, it really did affect where our marshmallow flew to.
Okay, so you're saying that the marshmallow size and the fact that we couldn't get the perfect marshmallow every time had a crucial role in this?
And yes, and the resistance of the friction on the marshmallow with a non-standard size object, of course, greatly affected whether or not it would go further or less far, or even spin to the left or right, or any of those things, whereas possibly something like a marble might have been a more consistent object to launch than a marshmallow, but I don't want to launch marbles today. So.
All right, Valerie, any other comments?
We just noticed too that how far you push the catapult down also affected how far the marshmallow flew. So we adjusted how far we pushed it to see what that would do to the trajectory.
Okay, energy flow. One more time just to wrap it all up. How did that energy flow through our little catapult system?
Well, we gathered the potential energy, we gave it the kinetic energy, and then we had friction loss, which is another kind of energy. And of course, we lost it all at the end whenever it hit the ground.
Okay, and the entire process is a mechanical energy process.
Just a reminder for our viewing audience, energy is neither created nor destroyed, only transferred. Thank you for joining us today at the 2015 STEM Symposium.